Welcome to today's edition of Long's Coffee Break. My name's Andrew Schmidt. I'm a sales engineer on our VRV team at Long. Throughout next year, my sales partner, Jeff McBride, and I will be hosting a series of coffee breaks that cover VRV best practices. We plan on covering design, installation, and maintenance and service. Today's our first in that series, covering VRV design best practices. We're happy to have Mike Condiff as our speaker today. Thanks, Mike, for joining us. He's the Northwest Regional Rep Sales Manager at Daikin. Take it away, Mike.
Thanks, Andrew. So as Andrew said, we're going to go through a series here covering, design, installation, maintenance, and service. This first one is going to be an overview of design, specifically, what you need to consider in colder climates like Colorado or other areas of the country that can get cold and snowy and all that kind of stuff. So let's see here. Okay, agenda. We're going to quickly go through the VRV benefits, why these systems are popular. Then talk about some of the cold climate considerations. Outdoor unit location is one that we see quite a bit in terms of things we need to think about in colder climates. Units and cooling all year. This is a surprising one, especially with DOAS systems these days and that kind of stuff, pushing systems into cooling at times you may not expect it. And some of the ways we need to set these systems up to accommodate that. Altitude derate, specifically for Colorado. We see some using this, some not using this, but just best practices in terms of sizing equipment for altitude. Design suggestions around refrigerant piping. This is another detail that sometimes gets overlooked. We're going to go through that a little bit. Schedules, specifically how you guys as design engineers put your schedules together and the information that you provide that can keep projects apples to apples out there. There are a lot of different systems these days to choose from. Just making sure you guys are getting what you want. And then I'm going to go through the low GWP refrigerant transition schedule and some of the more details around that. So that's what we're going to talk about. Okay, first, why VRV? I want to go through this quickly because I think it's important to understand all those sort of aspects or attributes of the system that have made it so popular over the last 20 years. The first one is it's very cost effective versus others, especially as an all electric system solution out there. It's high performance heat pump. You get a lot of heat out of these, more than most air source heat pumps. You've got the VFD compressor that has a great part load efficiency, and even in a place like Colorado with close to 0-degree design day, most of the time you're not at 0 degrees. You're somewhere between probably 30 and 80 degrees, and you can get pretty sunny days even in the middle of the winter time, which is nice when you can have the simultaneous cooling and heating. Optimized comfort. Everybody gets a thermostat that really wants one, so they're very easy to zone out. They're space efficient, a lot of architectural advantages for both new construction and retrofit projects. Quiet, you don't have compressors in the space. The condensing units are very quiet, so these systems are inherently quiet now. How they're designed. Electrically friendly, you do not have locked rotor amps or any of that kind of stuff on the outdoor unit. So for retrofit and new construction, even from an electrical standpoint, they're very friendly. And then package controls, all the controls for most small to medium sized buildings, regardless of manufacturer really these days, the VRF control system can do a lot of what traditionally you'd have to do with a BMS system. So those are the why VRV, the list of benefits that we typically see. But we do have to consider some things, especially in cold climates. So the first one that we're going to go through, and there are a lot more details here. So this is, in 15 minutes, it's tough to get through everything. If there's more to follow up on, please get with Jeff and Andrew to do that. So first one's outdoor unit location, especially a place like Colorado where you can get some large snowfall. Where these are located is important. Low ambient cooling, units in heating and cooling at times that you may not expect, and then that altitude derate. So first one, outdoor unit location. Just threw in a few pictures here of projects that we've been out to that, uh, on a set of plans, you may not really see what can happen when nature shows up. But first one up there in the top left, don't install units in wells or other locations where snow can pile up. You can see these are pretty buried there. These are down in a bit of a well. Obviously, this causes a heat transfer issue because you don't have any airflow through those coils, and they're going to be in defrost all the time because they can't defrost off the snow that piles up. Second one in the lower left, don't install snow where the snow can drift over them. These are showing some with some hail guards there that you can see that the snow is piling up in, and again causing heat transfer problems. You don't have the area there for the air to flow through, and defrost. Those things will never defrost with that ice buildup there against that with that snow. So to fix this, on the top right, do install units out of the prevailing winds or use wind baffles and snow hoods. And we say out of the prevailing winds. I don't think anybody expects anyone to have a windsock, making sure these things are on the leeward side of everything. But some thought should be put into it, especially if you have units that are completely, totally exposed on a roof with 40, 50 mile an hour winds in the middle of a snowstorm. Obviously that's going to affect performance a bit. So we have wind baffles that you can buy as an accessory, including the snow hoods up there. So those, Daikin provides those. There's other third-party manufacturers that provide them too. Really, the thing is to keep the wind off of the coils as much as possible. Bottom right, do install the units above the snow line. You can do field fabbed stands to get them up above the snow lines. There are other manufacturers like Bigfoot stands and things like that people use too, but just making sure that those things are not, in a place where snow is going to drift up on them and cover them over time. Low ambient cooling. So this is a surprising one. A lot of times for cold climates, especially, you'd think that all the fan coils are going to be in heating as soon as it gets below maybe 40 degrees outside or something. But they'll go through the specs first, and then we'll talk about, in my opinion, what some of those factors are that are leading to units being in cooling more than you would expect. So if you go to the top right up there, and our Mirion units is our newer line, you get negative 13 degrees in heating. So that's what they're rated down to. Aurora, you get negative 22 in heating. And then the heat recovery cooling operation standard, and this is pretty typical of most manufacturers, is going to be right around 23 degrees. So without anything, you can do cooling down to 23. You can do simultaneous operation down to 23. If it's going to be below 23 and you want units in cooling, or you expect them to be in simultaneous mode, we need to do some things to set those up for low ambient cooling. With our setup, we can get down to -4. So, if you look 20 years ago, you do not have DOAS systems really for the most part. ERVs are really not as popular as they are these days. So you had a lot of outside air load on these fan coils that would push these into heating mode most of the time. So these days we're seeing a lot of DOAS units taking the outside air load off the VRV system. So that's a large load in cold climates. So you're left with basically, from a heating standpoint, just skin load. Sometimes you have DOAS units providing warmer air than expected, creating false loads on zones. So I've seen some buildings that we go out to where the DOAS systems, providing, air warmer than set point. That's creating issues around, the units going into cooling and wasting energy for some of these projects. And then you have internal loads, people, computers, fireplaces, overcoming envelope loads, maybe due to, much more stringent construction standards with insulation and that kind of thing. All of these combine to sometimes make it so, units are really in cooling year round. So for Daikin, what we need to pay attention to is how we set up our low ambient system. So those include wind baffles and snow hoods. So we need those when you're going to be cooling under 23. And then we also have a dip switch setting on our BS box that we use. Other manufacturers do this differently. This is how Daikin does it. Here's an example actually I took this morning from a project in Detroit, Michigan. So it's 20 degrees outside. And this is a multifamily kind of veterans home. So it's a residence hall, basically. And this was all done with our Hero cloud monitoring service, which I'll talk about in a second. But if you look down to the bottom left down here, you can see 1, 2, 3, 4 units in cooling, only 1 unit in heat. And it's 20 degrees outside. And this is a residence hall. So you can see that I think this one had a DOAS system. I think the discharge error setup on this one, I think, is 68. But you can see how in real life sometimes these systems operate differently than you'd think purely from a load standpoint. And a little plug for our Hero Cloud monitoring feature. This is pretty new, but this allows you to do that real-time system diagnostic. It has all of the alarms built into it and all that kind of stuff. We're using this much more on projects. It is great to be able to look real time at what systems are doing out there. So if you have more questions about what this is, I'd say definitely get with Jeff and Andrew, and they'll tell you all about it. Altitude derate. This is another detail for specifically for high altitude places like Colorado. So make sure, and most manufacturers are going to have an altitude derate built into their programs, but make sure you're using that. So as you can see in the top here, the altitude was not accounted for. You get close to 39,000 BTUs. Sensible is at 32.2. Your max heating capacity is at 54. When you are accounting for altitude, you can see that drops down to 32,000 for max total cooling, down to 26.8 for max sensible cooling, down to 44.9 for max heating capacity. So this is something that's very important to pay attention to.
Just a couple more minutes left, Mike.
Yep. Confirm piping rules. This is another one that we need to pay attention to, and I'm going to kind of hurry along because the time's getting short. But again, if you need more detail, get with Andrew and Jeff. Piping design is important to look at. Scheduled capacities. This is another one. When you guys are designing jobs out there, I would recommend not putting in the nominal on your schedules. Make sure you put what is actually expected so that you get fair apples to apples system comparisons when contractors are looking at different manufacturers out there or whatever. It just makes it much easier to get what you're wanting. Low DWP R32 refrigerant transition reminder. So we have another year of R410A for larger 3-phase VRF systems. Those are all going to transition over Jan 1 of 2026. You get a year beyond that for R410A for new construction. And then I want you guys to all make sure that we understand that R410A systems will still be around even after the transition date for service and replacement for 3-phase systems. The EPA's come up with some guidelines around that. So for new air conditioning definitions, so need R32, and this is after Jan 1, 2026. If you replace all the outdoor units and 75% of the indoor units within a 3-year period, it's considered new construction. You need R32. If it's less than that, you're okay with R410A, and we are going to continue to have R410A equipment around indefinitely. So please contact the Long VRV team to schedule more in-depth presentations on any of the A2All transitions or any of this low ambient stuff that we went through, or new products, the Hero Pro, or any of that kind of thing.
All right, Mike, thanks for the presentation. Appreciate it. So this week's available prizes are $100 Papa Do's gift card, Beats earbuds, or this amazing valuable coffee mug. Get with your sales engineer will actually get with you to get you your prize. Thanks for attending, everyone. Have a good day. Bye.